Well, that's part of it. Maybe we will. Should we leave it in? What the hell? Okay, everyone, welcome to SAT Math Question of the Day with Professor Emeritus Seth Chaiken from the University of Albany and his brother Joel Chaiken. We're here to help you understand how to do SAT math questions, and more importantly, how to approach these things so that you can hopefully learn to approach them in these ways. We can't tell you what's on the test, but the approaches are generally all the same. So here's our question of the day. Two parallel lines, a shape. What is the length of CE? CE. Oh my God. Well, that's this distance. This distance here. Okay. That distance. Okay. So this is clearly a geometry question. I mean, it's clearly geometry. And one thing that should, in these questions, you really want to get right down to the essence. Like, what's the key to this question? And the key to this question are similar triangles. And if you don't see the similar triangles apply here, then you're going to have you're really not going to get the problem. But you must have seen, hopefully you've seen things like this in school. And as soon as you see something like this, similar triangles should pop out.
Okay, so why are these triangles similar?
These triangles are similar to be practical because many of you have seen this before, but they're also similar. You can tell the similar triangles for practical purposes by angle.
When they taught it in school, how would...
angle.
How did they teach in geometry? Okay. Why?
Angle.
Okay, one angle.
If you have two triangles and there are two angles in those triangles that are the same.
There's two corresponding angles.
Two corresponding angles. They have to be equal. So basically, it's called angle. You have to show that you have a pair of angles. You have two pairs of angles in the triangles, and they have to be congruent or equal, whatever. Right, exactly.
But there's more. You also have to have at least two pairs of angles have to be equal.
Right. Yeah.
Okay, so we have one pair of angles, one in one triangle, a corresponding one in the other triangle where the angles are equal.
Right, because they're vertical. Vertical
so what about the other angles?
Well, there you can write down the clue that these two lines are parallel, although I'm not supposed to use thick lines. I'm sorry. Those lines
That's all right. Yeah.
Those lines are parallel. And then we have parallel lines.
Well, the only parallel is one of the conditions given in the problem.
That's right.
So it's something to keep in mind.
Yeah.
So they're parallel.
In a geometry problem, you're always given clues. Clues are the big deal of geometry problems. You pay attention to all the clues, and you're lucky in geometry. Almost never do they give you extra clues. Okay, if in geometry, if you're given something, you're going to use it. Virtually guaranteed. So you have to use the fact that the lines are parallel to show that some of the angles are equal.
No.
What do you mean, no?
I'm sorry.
Oh, you made a mistake. Okay, at least it's not me.
I'm sorry.
Now you really made a mistake. Okay, get that.
Know.
Never erase.
All right.
Never stay away from erasing.
Yeah.
Use the back.
There we go.
Use the back thing to get the problem back.
Oh, sorry. Sorry about that.
Never erase. Just stay away from the erase button. Okay. Fine. So now you have one set of angles equal, the B angles. What I'm going to do is I'm going to use you use tick marks. That's fine. Yeah, little red marks are good. Okay, that works. Now, what other two angles are equal? Okay, you got angle D and angle A. Yeah, but you should make different tick marks to show.
I did.
Oh, you mean one is like a little thing and one's like a little sharp thing? You know what I like?
One is a round thing.
Yeah.
The other is a corner thing, and the other is a squiggly thing.
What I like to do is what's that? I like to use dots sometimes. Like there's a green dot there and a green dot there. Okay, fine. Okay, so now we've just shown that two angles in the triangles are there's two sets of congruent angles, which means these triangles are similar. I guarantee you, nobody taking this test will spend 4.5 minutes proving that these triangles are congruent. But we're doing it now.
The point of remembering geometry, even for application, unless you are going to become a real mathematician, is the point of the proving is to understand why things happen and to figure out problems.
Okay. That's a theoretician talking.
Yeah. So this is the that corresponding alternate angles across a transversal makes with a pair of parallel lines are equal.
Yeah.
Is a fact of geometry.
Right. Of course.
Okay.
Right.
And in the same way, at least two corresponding angles being equal in the triangle makes the triangles similar is a fact in geometry.
Right.
And now, what is the third fact in geometry about similar triangles that's relevant to this problem?
Yeah, the sides are corresponding sides are proportional.
Okay.
Corresponding sides are proportional. So you have to write a ratio.
Okay.
Right. You write a ratio. Okay.
Yeah. So what are corresponding sides is?
Right.
This is this one and this one are corresponding sides.
Wait, which sides are corresponding?
This one.
The 5.
And this one.
And the 10. Yeah, now how did you know that? I know how I knew that. How did you know that?
Well, because they are opposite corresponding angles.
Right. That is the secret. I always talk about snow poles. You know what a snow pole is? You live in Albany. You've seen snow poles in the country?
Yeah.
You know, where they have the guides? The guide to a similar triangle problem are the angles. The angles tell you which sides are proportional.
Yeah. Right. So the sides corresponding to equal angles are proportional.
Right. Exactly.
So
that's right.
The proportion of the top of the lengths of the top to the bottom triangles are from this 5 to 10.
Fine. So we can put a 5 here and a 10 here, and we'll say this is the top one and this is the bottom one. And then we go the top one and the bottom one. Now we're going after what we need to find out. What is the other ratio? We go to the other set of equal angles, which happen to be the green ones.
Yeah.
My green ones and Seth's like D and A. So now we go against the sides, against the green angles.
Well, another way to see it is that the top and the bottom sides are corresponding.
Yeah.
And so as soon as you realize that CB corresponds to BE and the other pair are the top ones, that leaves only one more possibility. And so that other pair of lines must be DB and BA. Right. So you don't have to go through an extra step of reasoning. You don't have to go through an extra step of reasonings and think about the angles across from CB and BE being equal.
Okay. Yeah. Okay.
Okay. So the problem is this is an unknown length that helps you get the answer. Of course, the answer is this unknown length plus 8.
Well, of course, right? Exactly.
Okay.
Yeah. So then here's your proportion, and then
you can solve it.
Well, okay, there are different ways to solve it. Many people will just see that it's 4.
Well,
Many people will see that x is 4. Some people will cross multiply.
Yeah.
40 is equal to 10x and just get it. But many people will just look at this and say, well, x is 4.
Well, many people will see that the top triangle is half the size in measured in length as the bottom.
Right. Yeah, that's the other way.
The ratio is 1 to 2.
That's right. The similarity ratio.
And so they'll immediately think that the corresponding line on the top triangle is 1/2 of the length of the corresponding side of the other triangle. Right. Yeah. So this question mark length is half of 8, which is 4.
Right.
And then to get the answer is simply 8 plus 4,
Right, that's right.
which is
That's
12.
right. It's frustrating because there's going to be a decent percent of people, maybe what I would say 15-20% of the people that will answer
Who
4.
knows?
That will answer 4 because they will not have. They will not.
Yeah.
They this happens all the time, right? So be really careful on an
Yeah.
SAT
Yeah.
question.
Yeah.
It's really frustrating to get a question wrong when you totally understand it. You got this problem down,
Yeah.
but you don't answer the exact question. It's really frustrating.
Well, so maybe a good idea to mark to yourself that is the length of segment CE is what they want.
Right. Yeah.
And
well,
that is what I drew early on in the problem.
Right.
And I put a question mark here, but to emphasize it, I'll put a really big question mark here.
Yeah.
To remind you that this is the answer.
Right.
Which is not, that answer is not the the little pair of question marks.
Yeah. That's why, like, when I did it, I used the blue heavy line, but I like sass.
Yeah.
See, you probably can't bring colored pencils to the SAT, but you could definitely mark your paper up with a big thick black line. Go like this. But if you do that, you may cross off the 8, right? So you have to be careful. But I like the way Seth did it, actually. I like the way he did it because he extended it out. So it's really staring you in the face. It takes a little more time, maybe a second and a half to do that. But if you do that, it's really staring you in the face. You got to be careful. Wow. Okay. So this is good. This is good. My final suggestion is think of the angles. Go for the equal angles in the similar triangles, because the sides opposite the equal angles are the sides that are proportional. Yeah. So I guess that's it, right?
Yeah, we did it.
The case of similar triangles, geometry, similar triangle problem. Okay, everyone, have a great day. And, please, I forgot, like us, dislike us, comment on us, give us any comments or welcome, destructive, constructive, anything, so that we get some feedback as to how we can better make these videos for you. Okay, take care, everyone.